Welcome to Nationalize. Please subscribe and hit the bell icon for more breaking updates. The world is changing, and the electric vehicle revolution is here. More cars are plugging in, promising cleaner air and quieter streets. But the heart of every EV, the motor, has relied on rare earth magnets and heavy copper coils, which are costly and environmentally damaging. This has been a major roadblock to truly sustainable transportation. Now, a quiet revolution is happening inside the electric car. Engineers worldwide have asked, can we build motors without these problematic materials? In late 2024 and 2025, the answer arrived: yes. New motor designs eliminate magnets and even copper coils. This is a giant leap forward, not just a small step. These innovations are game changers for the world. Imagine EVs that are cheaper to build and don't depend on a handful of countries for critical materials. This strengthens economies, secures supply chains, and finally delivers on the environmental promise of EVs. We're talking about reducing a car's carbon footprint before it ever hits the road. This story is about a better future, starting from the inside out. We'll explore the problems with traditional EV motors and dive into revolutionary solutions from ZF, MAHLE, Valeo, and KIST. We'll see how these new motors work and the huge impact they'll have on our economy, environment, and society. The future of transportation is being rewritten right now. And it all starts with these groundbreaking motors powering the next generation of electric vehicles. To see why these new motors matter, let's look at how current EV motors work. Most use permanent magnet synchronous machines, rotors with rare earth magnets and stators with copper coils. This design is efficient, but it comes at a cost. Rare earth elements like neodymium and dysprosium are tough and dirty to mine, creating a large carbon footprint. So the green car starts life with environmental debt. The supply of rare earths is also a political and economic risk, concentrated in just a few countries. This makes prices volatile and supply chains fragile. For automakers, it's a big risk. Costs can spike, supplies can be cut, and planning becomes difficult. Then there's copper. It's heavy, and heavy motors mean less efficient cars with shorter range. Engineers are always trying to reduce weight to improve performance. The heavy copper and problematic rare earth magnets have been two of the biggest challenges holding back EVs. These materials make EVs more expensive and less sustainable. The industry has been searching for a way out of this contradiction for years. Now, with new motor designs, that breakthrough is finally here. The next generation of EVs can be lighter, cheaper, and truly green. The revolution isn't just about what powers the car, it's about what powers the motor itself. By rethinking the motor, we can unlock the full potential of electric vehicles. The future of mobility depends on solving these material problems. And that's exactly what's happening now. The first major breakthrough came from German supplier ZF. In December 2024, ZF won a Top Innovation Award for its I2SM motor, in-rotor inductive excited synchronous machine. The idea is simple but revolutionary. Create a powerful magnetic field in the rotor without any permanent magnets. No rare earth metals means no environmental or supply chain headaches. Instead of magnets, ZF's motor uses a wireless inductive transmitter to send energy to coils inside the rotor. This is like wireless phone charging, but for a spinning motor. The magnetic field can be controlled electronically, unlike permanent magnets. This means less drag at high speeds and better efficiency on highways. ZF's I2SM matches the power and torque of the best magnet motors, and sometimes beats them. It's a sustainable alternative that doesn't sacrifice performance. Winning the Green Category award shows how significant this is. Automakers now have a high-performance option free from rare earth problems. This is the first step toward a new standard for EV powertrains. The industry is shifting, and ZF's innovation is leading the way. The future of EV motors just got a lot brighter. As ZF made headlines, MAHLE and Valeo launched their own breakthrough, the IB motor. The IB goes even further: no rare earth magnets and no traditional coils needing physical contact. MAHLE's magnet-free contactless transmitter sends power wirelessly to the rotor. Valeo's advanced control software manages the electricity with precision. The result, a compact, robust, and powerful motor for the next generation of EVs. The IB delivers up to 350 kilowatts, enough for high-performance cars, with over 95% efficiency. It's 30% more power-dense than conventional motors, saving space and weight. Most importantly, its carbon footprint is 30–40% lower than traditional EV motors. This is a huge step toward making the entire EV lifecycle greener. Real-world tests are underway and commercial use is coming soon. The IB isn't just a concept, it's a practical, sustainable solution. Cleaner, more powerful, and more efficient, the IB motor is ready to change the game. The future of EVs is arriving faster than anyone expected. While Europe focused on magnets, South Korea's KISS team dreamed bigger. In June 2025, they unveiled the world's first fully functional electric motor with no metal at all. Instead of copper coils, they used carbon nanotubes, ultra-light, super strong and conductive. For years, making pure conductive CNTs was a challenge, but KISS's new purification process changed that. The result, a motor coil material with a fraction of copper's weight, just 1.7 grams per cubic centimeter versus copper's 8.9. A CNT motor can be over 80% lighter than a copper one. For EVs, that means better efficiency and longer range. For drones and electric aircraft, lighter motors are a game changer. KISS's demo car, powered by CNT coils, proved the concept, even if it's early days. The CNT wires weighed just 78 milligrams compared to 379 for copper. Dr. Daeyoon Kim says this is just the beginning. As CNT technology improves, ultralight motors could transform electric mobility on land and in the air. The future isn't just magnet-free, it could be metal-free. The possibilities are enormous. How do these new motors work? Let's simplify. Traditional motors use permanent magnets in the rotor and copper coils in the stator. The stator's magnetic field spins the rotor's magnets, creating motion, but the magnets are always on, causing drag. The new motors replace permanent magnets with coils in the rotor. Power is sent wirelessly, like a phone charger using induction. This lets engineers control the rotor's magnetic field, strong for acceleration, weak or off for cruising. The result, less drag, more efficiency, and better real-world performance. KISS's CNT motor uses the same principle but swaps heavy copper for ultra-light carbon nanotubes. Imagine replacing steel chains with carbon fiber ropes. Same function, less weight. The key advantage is weight reduction, unlocking new possibilities for EVs, drones, and more. These motors are smarter, lighter, and more efficient. The future of electric motion is all about control and materials. The impact of these motors goes far beyond engineering. The EV industry's reliance on rare earths has made supply chains fragile and prices volatile. Magnet-free and metal-free motors break this dependency, making supply chains more resilient. This shift enhances economic security and reduces geopolitical risks for automakers. Removing rare earths can lower EV production costs, making electric cars more affordable. Cheaper EVs mean faster adoption, more jobs, and a bigger green tech market. The race is now about innovation, not access to raw materials. Any country or company can compete, leveling the playing field. These motors democratize electric mobility, making it about engineering, not geology. The global auto industry is being reshaped by this quiet revolution. The future belongs to those who innovate. The promise of EVs is a cleaner world, but that starts with manufacturing. Mining rare earths is destructive, using harsh chemicals, water, and leaving toxic waste. Magnet-free motors cut out the most damaging part of EV production. MAHLE and Vallejo's IB motor has up to 40% lower carbon footprint than conventional motors. Lighter, more efficient motors extend EV range, making them practical for more people. Lower costs mean EVs are accessible to more households, not just the wealthy. Ultralight motors like KISS's CNT design could revolutionize urban air mobility, drones, air taxis, and more. These breakthroughs ripple outward, enabling smarter, cleaner, more efficient cities. A single innovation in motors can transform how we move and live. The road to a greener future starts inside the motor. The electric vehicle journey has reached a turning point. Magnet-free, coil-free, and even metal-free motors are reinventing the heart of the EV. Companies like ZF, MAHLE, and Vallejo are pioneering motors that deliver top performance without rare earths. KISS's carbon nanotube motors could redefine what's possible on land and in the air. These are giant leaps, not small steps. The impact: stronger economies, a cleaner planet, and more accessible transportation. As Dr. Otmar Scharer of ZF said, we can have performance and sustainability. No more trade-offs, just progress. These motors are more than technology, they're enablers of a better future. The next time you see an electric car glide by, remember the innovation inside. A quiet revolution is underway, driving us toward a brighter tomorrow. The future of transport is being rebuilt from the inside out. The road ahead is electric, and it's greener than ever.